kids. Today I'm going to do a warm-up with you before the lesson. So normally we do this when we do our live sessions, but this one is a little bit long. Plus it really does lead to, it's an important skill for what we're going to do today. So I want you to notice that every single one of these functions on the left, forget about the inequality right now, on the left is a function you are supposed to know from prerequisite classes. Negative 2x plus 10 is a linear function with a negative slope. Negative 2x squared plus 10 is a parabola that opens down. Negative 2x cubed plus 10 is a cubic function and behaves like a line with a negative slope. Absolute value minus 2 is a v that opens up and is shifted down 2. E to the stuff, right? E is just a number a little bit smaller than 2. E raised to to whatever is slide swoosh. Okay, so I think those are the things I think about before I am ever asked, before I ever look at the right. So think about now what this is saying to you in English. When is this graph above 0? But that's above the x-axis. So do you quickly know when a linear function is equal to 0, right? Notice I said equal. So my strategy was negative 2x is equal to negative 10 equal to, x is equal to 5, right? So this linear function has an x-intercept at 5, and I want to know what is true about when this graph is above the x-axis, right? If this is at 5, 0, that's crossing the x-axis there. So when is this graph above the x-axis? When x is less than 5, right? So being able to think about that graphically. How about this one? Right? I know it's an upside down parabola, but where does it hit the x-axis? Where is this upside down parabola above the x-axis? Well, when is negative 2x squared equal to negative 10? When is x squared equal to 5? It's when x is equal to plus or minus root 5, right? The x-axis, negative root 5, 0, positive root 5, 0. So where is this graph above the x-axis? See what would happen if you forgot how many things can you square and get 5, right? You're not simplifying a radical. You're solving a quadratic equation. So how about the next one? When is negative 2x cubed equal to 0? Well, that's when it's equal to negative 10. X cubed is equal to 5, so x is equal to the cube root of 5. Cube root is 1 to 1, right? So here's the x-axis. When does this thing hit the x-axis? Whatever the cube root of 5 is, 0. When is that red graph above the x-axis? It is when x is less than cube root of 5. Now remember, I could write this way. There's lots of ways I could write the answer. It doesn't matter which way you write it, as long as you can read it any way I happen to write it to you. So how about this one? You know, this one has just been shifted down. This is 0, negative 2. So where is this absolute value above the x-axis? Where does that hit? If you know that for absolute value, the slope to the right of the vertex is up 1 over 1, up 1 over 1. Well, that x-intercept is 2. up 1, left 1, up 1, left 1. That x-intercept is -2. So there are two separate pieces. So you must write this as two separate statements. Notice there's an equal sign this time. So when x less than or when x is less than or equal to -2, or when x is greater than or equal to +2. And I want to make sure to really make sure you understand that because there are two pieces of the graph that make this statement true, where is the graph less than or equal to 0? Oh, I said less than, didn't I? Darn it. I did that on purpose. Because since it is less than, I gave you the greater than. But notice the greater than statement does involve two pieces of the domain. I went back and I checked my answers, and I want it to be less than. When is this graph under the x-axis? I can write this as one statement. X is between -2 or 2. And that was the same up here in in number 2. Notice that the x values that satisfied where the graph is above the x-axis was one piece. So I could write one domain statement. But if your solution is in multiple pieces, you must write this in two statements, or however many separate pieces there are. Now remember, this is the answer to the absolute value of x minus 2 being greater than or equal to 0. So this one, e to I don't care, right? Slide swoosh, where's the horizontal asymptote? E to 0, e to the 0 is 1. E to negative numbers is just 1 over e to the. E to positive numbers is e to the. This graph, because you know the range of an exponential function with a base that is greater than 1, this graph will never be under the x-axis. Right? I didn't have to do any math with that. It's just because I know what the graph looks like. I don't care what this is. This is, right? E to the 0 is 1. E to positive numbers like 5 is 2.7-ish to the 5th power, which is positive. E to the -5, let's say. Well, I guess, yeah, if -2x plus 5 is equal to 10 or whatever. But e to negative numbers, right, is 1 over e to the 5th, which is still a positive number. E to 0, e to positives, e to negatives are always positive answers. You will never have that graph be below 0. So notice for 11 and 15, I give you a hint here that you're going to need the rational root theorems, Descartes, and division to answer. Ooh, that sounds scary. All right, so if you haven't guessed so far, this is prerequisite knowledge. Solving inequalities in one variable. So I know we took a break on purpose from solving equations in one variable to solving inequalities, right? We wanted the brain to rest a little bit on the solving equalities. We did a couple of days of partial fractions in between there. And then now we're going back to solving inequalities. So the most important thing for you to understand, and this comes from the 18-wheel song back in AAF, is that all real numbers are either positive, negative, or 0. There are some operations I can perform with real numbers that cause me to go outside the set of real numbers, which for us is undefined, right? Unless otherwise specified, you are working under the set of real numbers. So when I look at this polynomial, I am not trying to solve it over the set of complex numbers. I just want to know what real values make this function equal to 0, positive, negative, and is there any operation that would cause me to be outside the set of real numbers? Well, I can answer this easily. F of x is a polynomial. It's an x to the first, an x squared, and an x squared. This is a polynomial. Polynomials are always defined everywhere. So there is no real values that make this function undefined. Nope. Polys have a domain of all real numbers, right? Now, what makes this polynomial 0, positive, or negative since I've eliminated undefined? Now, I can kind of get a picture of this, right? If it's a first, second, and second degree, right? I know I have a fifth degree. The leading coefficient is positive. It opens up. So I make myself my strategy. Step 1 is to make myself a handy dandy number line. We took you through this process in AAF for just quadratics to introduce you to this number line work. And this number line work is going to come up again in calculus, where you are investigating what makes an equation equal to 0, and then using 0 as the great divide between the positives and negatives. So step 1, make a number line with the values that create 0. On the number line. So do you see where I got -3 and 4 from? Right? If I put -3 into here, -3 plus 3 is 0, and 0 times I don't care is 0. If I put 4 into here, 4 minus 4 is 0, 0 squared is 0, times I don't care is 0. Hey, how come I don't have -1? Yeah, this factor is a prime quadratic. It is not equal to 0. Right? There's nothing I can put in for x, square it, add 1 to it, and make this factor equal to 0. So there are only 2 zeros. So this is great. So I know this fifth degree crosses the x-axis twice at -3 and 4. But now I want to ask you, what happens below -3? What happens below -3? And here's what you need to believe. Because polynomials are continuous and the domain is all real numbers, and -3 and 4 are the only values that create 0, and because of continuity, if you are negative before 0, the only way you can change to a positive is by passing through a 0, right? So test any number below -3, any number at all. For instance, -4. Choose -4. Now, go up to the fact, please do not multiply this out. Think. -4 plus 3 is negative. This factor will always be positive. -4 minus 4 is -8. Don't care. This factor is always positive. What happens when you plug -4, -4, -4, and you get a negative factor times a positive factor times another positive factor? What happens? Negative times a positive is a big fat negative. If you had chosen -40 or -40.2 or -400.2, it wouldn't matter. These factors, the first factor would be negative and the second two would always be positive. If you put in -3, you get a 0. What happens after -3? Choose a number in between here, maybe like 0. So I'm in the second section. Think 0. 0 plus 3 is positive. I already know the other two factors are always positive. What is a positive factor times a positive factor times a positive factor? Pick any number above 4, like 1,000,000. Think 1,000,000. 10 to the 6th. What is 10 to the 6th plus 3? The other two factors are always positive no matter what I put in. So this section is always positive. So this can also help me graph, right? If I know the leading if I know this is a 5th degree and I know the end behavior is here and here, I know the x-intercept is at -3 and 4. I know I have a multiplicity of 2 at 4. So I know that's a kissing x-intercept. And this is a crossing x-intercept. Looks something like this. Well, that's terrible, terrible. But that's not our objective this time. This time, our objective is to solve an inequality. So what if I change this question and I say, I want to know, I should say that I should label that x, I forgot. And f of x, right? What x's are you choosing? Oh. What x's are you choosing to generate these values, and what y values are you getting out? What if I changed this gosh darn it, I did it again, didn't I? What if I changed this question and I said, what makes x plus 3 times x squared plus 1 plus x minus 4 less than 0? Now you are solving an inequality in one variable. Do you see your answer? It's right there. What if I had asked you what makes that, and again, think about the graph that I drew that I erased. There's where the graph is always under the x-axis. What if I had asked you, when is this graph greater than or equal to 0? There it is. Right? So the warm-up problems were all algebra 1. Those were all equations that you should be able to think about graphically. I can think a little bit about this graphically, right? Because it is a polynomial of a 5th degree, so I can verify and think about without a computer in my hand. But how I got the actual values was using this number line strategy. So again, remember, since I erased it, step 1 was a number line. Step 2 was choose a value in each section. Determine y values of each section. Right? So that's what we did here. We chose a -4 and the y values were all negative. We chose 0, which meant that in this section, the y values would be all positive. We chose 1,000,000 and got a positive result, which means everybody to the right of 4 is positive. Even if you had chosen 4.00001, you would still get positive because you can't pass into the negatives without going through zero. That has to be so when you have continuity, which is why continuity is so important. And then step 4 is answer the question, right? Were you asked, where does the function equal 0? Were you asked, where does the function above the x-axis? Were you asked where the function is below the x-axis? So let's try this one. So notice again, for right now, I am still sticking with an equality. That's not the kind of question you're going to get. You're going to get an inequality like this. Okay, so do you see the difference in the directions? This is really the problem you're going to get. Solve an inequality in one variable. This is really the prequel step. This is the prequel. I see this, I think this. Further, I really think this. So what do I have here? A second degree, a first degree, and another second degree. So this is another 5th degree polynomial. Polynomials are defined everywhere. So I'm going to make myself a number line. Freak. Replace that with 0. Think equality. Don't think inequality yet. Make yourself a number line. Step 1. You can use X, I don't care, but they gave me a T, and I'm going to say, what are my Y values? So what values of T create 0? 3, -4, and what? And what here? Be careful. What would go here? What is that really? What number can you put in for T, square it, negatize it, and subtract 2? Right? Isn't that really negative T squared plus 2? Right? You see what I did there? What does that graph look like? Right? You're negatizing this. That's an upside down parabola, right? Or just, you don't even have to think about that. You can just think, right? This is a parabola that opens upside down and its maximum is at -2. This is always negative. There is no value here that will create 0 because you're going to have a positive number, negatize it, and then subtract 2. So negative, right? Always negative. So the only numbers I'm putting in here, on my number line would be -4 and 3. Both of those values create 0. Now, don't forget about this dilation factor, right? I still have to multiply, whatever I'm doing, I have to multiply by 2. But 2 is always positive. So pick a number, step 2. Pick a number below -4, like -5. So you have a +2. -5. Oh, wait a second. This is squared. Isn't this always going to be positive as well? Put -5 in here. -5 plus 4 is negative. And we always said this is always what? Negative. So what is a +2 times a positive times a negative times a negative? A positive, right? Repeat. Pick something in here, like 0. +2 times something that is always positive times 0 plus 4, which is positive, times something that is always negative. What is that? A positive times a positive times a positive times a negative? A big fat negative. How about something above 3, like 3 million? I mean, no, you don't really have to choose 3 million. I'm just being facetious, but showing you it doesn't matter what number you pick above here as long as it is bigger than 3. You have a positive 2, a factor that is always positive because it's squared. 3 million plus 4 is positive. And then you have a factor that is always negative. So what is a positive times a positive times a positive times a negative? A big fat negative. So do you see how I now can solve this equation? Right? So step 1, number line. Step 2, choose a domain value in each section. Step 3, evaluate what the y would be. Right? I chose -5, the y's are positive. I chose I chose 0, the y's are positive. I chose 3 million, the y's are 0, the y's are negative. 3 million, the y's are negative. Right? So I can now solve this inequality in one variable. When is this expression positive or above the x-axis? Not included because it's not greater than or equal to. Okay, let's do another one. So this time I didn't write the prequel step. But you need to know you can't solve until you are equal to 0. So step 1. Think equal to 0. Factor. Notice in the steps, I didn't write down all the prerequisite steps, right? This is prerequisite knowledge. Now I am starting, right? I have the factored form. So the assumption is that you can take an expression and get it into factored form. And now, here's my handy dandy number line. What values of x create 0? This time I am, right? X and y's, which come from f of x. I don't have to write f of x if you don't want. It's y, right? 0, certainly. 4 and 2. I didn't do a very good spacing job. Now, choose a number in each section. So pick a number like -10 or -100 or -1, doesn't matter. I will be multiplying times a negative value. -10 minus 4 is negative. -10 minus 2 is also negative. What happens when you multiply a negative times a negative times a negative? Choose a number like 1. I will end up with a positive times a negative times a negative. Which is what? A positive times a negative times a negative? Positive. Pick a number between 2 and 4, like 3. 3 is positive. 3 minus 4 is negative. 3 minus 2 is positive. So what happens when you multiply 2 positives and a negative? Pick a number above 4, like 400. Plug it in for x, and I get a positive, another positive, and another positive. What was I asked? What makes this cubic function greater than or equal to this linear function is the same question as to what makes this different cubic equal to 0. But now I can answer also what makes that different cubic greater than or equal to 0. And where are those? I can see them. So from 0 to 2, all the infinite numbers in there, and then from 4 and above, all the infinite numbers there. Yes, you can write union. Yes, you can write this a lot of different ways. Don't care, as long as you can read it anywhere, any way that is given to you. So if this was gross, right? This problem, this particular problem, depended upon the fact that I could factor nicely. And you do have to be able to factor nicely. But what if it wasn't nice? What if the roots were like 1 plus or minus root 3? Well, you could do this with a calculator, right? And that's the importance of being able to understand the graphical relation that, yes, between 0 and 2 and between 4 and above. Two separate pieces require two separate statements as to where you can find all the values of x that would create a positive graph, or a graph that was equal to 0. Okay, so again, this one wouldn't be given to you with a calculator, but if I did ask you to solve an inequality and asked you to do it with a calculator, I would expect you to do this. I would expect to see that you had to set it equal to 0, and then I would expect you to use your calculator, and I would expect you to be able to answer. Or I would expect you to put this in y1, this one into y2, and find the intersection. But what's important is that you communicate what you do, right? So I could draw a graph would be one way to answer a question if I had a calculator in my hand. So I would draw this graph and this graph, right? And again, I think it'd be a little bit harder to say when is it bigger than this line, right? I think it is much more efficient to set it equal to 0, and that way you're looking at where it's above a horizontal line instead of above a diagonal line. But you know what? You do you. It is important to know when you are dealing with a polynomial, you never had to think about being undefined. So you can imagine what's coming, right? Uh-oh, I don't have a polynomial. So this time, what real values make f of x equal to 0? And again, this is my function, right? I can call it, and I should call it f of a, shouldn't I? If I'm going to go ahead and use a in there. 0, positive, negative, and undefined, right? I had undefined in those other problems, but I didn't really need to, because as soon as I recognized I had a polynomial, I wasn't worried about being undefined. But as soon as I see my expression has a fraction, I am worried about undefined. When else would you worry about being undefined? Right. If you had a radical, or if you had a if you had logs, right? Now, logs, you have domain issues. Some trig things, you have some domain issues. So what am I worried about here? I am only worried about what makes the denominator equal to 0. So look at my number line this time. Right? I know a rational function might have discontinuities, but I know it's continuous everywhere else. So the issues are at -3 and at 1. -3 makes my function undefined, right? And I don't care if you write DNE or undefined, doesn't matter. The value of 1 makes my function undefined. but everywhere else this function is continuous. Now, if I know where it's undefined, the next thing I'm going to go after is what makes this rational function equal to 0. And remember, we said if a fraction was equal to 0, what must be true? The numerator must be equal to 0. So what value of a makes this numerator equal to 0? Now what are you going to do? Yep, test. So pick a number below -2, pick a -3. Why did I write -2? Like -4, -5, -50, don't care. Pick a number between -3 and -0.5. That's where I was thinking -2. Pick a number between -0.5 and 1, like 0. Pick a number above 1, like 2. And say to yourself, what's happening? Now, this one is a little more challenging because it's a fraction, right? So I have to say to myself, if I plug in -5 into my numerator, what do I get? -5 into my numerator makes my numerator negative. But what about my denominator? -5 plus 3 is negative. -5 minus 1 is also negative. So I have a negative over a positive, which makes a negative. How about here? How about at -2? -2 makes my numerator still negative, but my denominator, -2 plus 3, is positive. -2 minus 1 is negative. So then I have a negative over a negative. Which means that section is positive. How about between -0.5 and 1? I'm going to pick 0. Put 0 in for a, and I get +1 over a positive times a negative, which is a negative. And then something above 1, like 2, makes my numerator positive, and my denominator, one factor is positive, and the other factor is positive, so I get a positive. What was I asked? When was this fraction negative? Or the graph of that rational function under the x-axis? I see it, do you? So negative infinity to -3 and -1/2 to 1. Crazy. Let's do another one. What is happening? What is happening? Oh my gosh. There's all kinds of crazy things going on here, right? This is where you calm and use your factoring brain. What's going on? Whoops, sorry. What's going on? I have a fraction, so I'm worried about division by 0, and I'm also worried about a radical, which means I can't have things less than 0, right, under here. But, so what does this mean? Now look at z. Z is being squared, isn't it? So What numbers create issues? -4 creates an issue because that creates 0 in a denominator, and I can't have that. Also, I can't put anything in below -4, right? If you put in -5, -6, negative whatever, you can't put that. You can put that here, you can put it here, you can put it here, but you cannot put it here. So this part of the number line doesn't exist for me, starting at -4. What other number creates an issue in the denominator? 0, undefined. Right? So I've taken care of, remember, I've left off the directions now. So really, the first thing, because I have a fraction and a radical, the first thing I thought was undefined. The next thing I think is what makes 0. When we have a fraction, what do we think? What do we say when we have a fraction? What makes the numerator 0? -2 and 3 create 0. So now I've got to pick values in between each one of these sections. I got to pick a number here, pick a number here, pick a number here, pick a number here, and evaluate. I will leave that for you to verify, but I will tell you that I got that's what I got. So what do I want to know? Greater than 0. So where am I greater than 0? From -2 to 0, because I'm undefined at 0. From 0 to 3, can't include 3 because I'm 0 at 3. And from 3 to infinity. Remember, this is always positive because I'm squared. This is always positive because I'm taking the square root of legal numbers. This is always positive, right? So in reality, the only thing I had to worry about was, when was this linear factor negative? Before -2. Uh-oh, more fractions. Prerequisite knowledge. Combine that into one fraction. This time I want to be greater than or equal to. Notice I don't multiply out the denominator. I am undefined at -2 and 3. 0 at 1/2. Test values. Below -2, in between -2 and 1/2, in between 1/2 and 3, and after 3. Test a value, and again, I will leave it to you to do that, but I ended up with negative, positive, negative, and positive. What was I asked? Positive or equal to 0. So -2 can't include that because that's not 0, that's undefined. 2 1/2 included. And then again, 3 is undefined. So you can't include 3. One more. Come on, you can do it. You can do it. One more. Crap. What is this? Why is there absolute value in there? Oh my goodness. This is a fractional function, but it is not a rational function. Rational functions are the ratio of two polynomials, not a polynomial, not a polynomial. Good grief. But notice, just like before, -4 creates 0 under that radical, but that radical's in a denominator, so undefined. And I want you to reflect upon your AAF experience, how many times we asked you to look at fractions and put weird things in the denominator, right? Very beginning of AAF. So none of this part of the number line exists for me. Hold on one second. I will be right back. Good boy, dude. Oh my goodness, I left something on the stove and Mr. Getz is not home. And thank goodness my dog started making noise downstairs while it was smoking. Ah! Everything's fine. It's a little smelly in my house, but everything's fine. Calm. Get back to solving inequalities in one variable. Goodness, my heart is pounding. All right, where was I? Okay, all right. I have taken care of the denominator. What makes the numerator equal to 0? Certainly -2 creates 0. And what else? Yeah, 1, right? Because 1 minus 1 is 0. Absolute value of 0 is 0. And now pick values and test. I don't have to test anything on the undefined part of the number line. So pick a number in between here, here, and here. Y values are negative here, positive here, and positive here. And again, hopefully you can think about that same situation where, hey, since I've eliminated undefined, everything here, this will always be positive. Anything coming out of absolute value is always going to be positive, or 0, but I've already taken care of that, and I took care of the 0 here too. So the only the only thing I have to worry about is when is this linear factor equal to 0, and then when is it greater than 0 was really all I was being asked. Since this time I am not including 0, right? There's no inequality. There's no equal sign underneath there. Oh, wait, I made a mistake, didn't I? I think it's because I almost burned my house down. What did I forget to write above the 1? The 1 creates 0. And am I asked about 0? So this is a minor mistake that I would get follow-through points for if I forgot that. But remember, since I didn't include 0, I have to say -2 to 0 not included, 0 to infinity. And yes, before you ask, Yes, there are other correct ways of writing that answer. As long as you communicate correctly, mathematically correctly, it doesn't matter unless the problem dictated notation, which this one didn't. You can write it any way you want, write it correctly and efficiently in a testing situation, and you will be fine. You were just responsible for reading any kind of notation, right? So I could say x is between -2 and 0, and x is greater than 0, all that. Oh, Mr. Getz is home. He probably wants to know, why does the house smell like I tried to burn it down? I know, I tried to burn the house down. Sorry. Talk to you later. Bye.